You know, when it comes to artificial intelligence, trust, that's always been the big missing piece, right? We build these amazingly powerful systems, but can we ever really be 100% sure they'll do what we expect? Well, today we're looking at a breakthrough that wants to swap all that uncertainty for a cold, hard, mathematical guarantee.
So let's just jump right in with this question. What if we could actually prove, with math, before an AI even starts its work, that it will find the absolute best answer, every single time? I know, it sounds like something out of a sci-fi movie, but it's the core promise of a new method that could totally redefine what we think is possible with AI. But first, before we get to the solution, we've got to understand the problem. Because for all their power, a lot of today's most advanced AI models have this hidden flaw, this crisis of unpredictability that makes them, frankly, a huge risk for the really important jobs. And this analogy, it's perfect. Imagine an AI's job is to find the single lowest point in a huge mountain range. That's the best solution. But the whole landscape is covered in a thick fog. So the AI goes downhill, finds a valley, and thinks, aha, I'm at the bottom. But because of the fog, it can't see that there's a much, much deeper valley just over the next ridge. It gets stuck in what's called a local minimum, completely convinced it found the best answer when it's not even close.
Yeah, this lays it all out, clear as day. On the left, you've got the reality for so many systems right now. They get lost, they give you different answers to the same question, and you just can't trust them with things like medical diagnoses or running a power grid. But on the right, that's the dream. An AI that is totally consistent, completely trustworthy, and just safe, because it's mathematically guaranteed to find the one true answer, every time.
So, how in the world do we get from here to there? Well, the answer is in this beautifully simple mathematical idea that works like a new kind of compass for AI, one that literally never gets lost. And this is the absolute heart of the solution. It's called convex optimization. Instead of trying to navigate that foggy, treacherous mountain range, you mathematically reshape the entire problem into a simple, perfect bowl. And what's so amazing about a bowl? It only has one bottom. That's it. You can drop a marble anywhere inside, and it is always going to roll to the exact same spot. There are no other valleys to get stuck in. The best answer isn't just likely, it's an absolute guarantee. And the person who engineered this brilliant breakthrough is Gazi Pollob Hussain. What makes this story even more incredible is that he's a self-taught AI pioneer. He was driven to solve these really deep, fundamental problems of AI trust and stability, basically from the ground up. And you can really hear the vision in his own words right here. This isn't just about making AI that's a little bit better. It's about building a future where our most powerful tools are provably reliable, certified for safety, and guaranteed to be ethical. Okay, so you're probably wondering, how does this actually work? How do you turn a mountain into a bowl? Let's pop the hood and take a look at the math that makes this all possible. All right, the official name for this whole process is the Convexity Transfer Methodology, or CTM for short. And its entire job is to be that kind of magical translator, taking a messy, complicated mountain range problem and reshaping it into a clean, simple bowl problem where the solution is a sure thing. And this breaks it down beautifully. First, CTM scans the whole problem to understand its shape. Then comes the secret sauce, the Hessian compass. This is a special math tool, the Gazi Pollob Hussain Hessian matrix, that creates a perfect topographical map of the entire problem terrain. Using that map, CTM applies a mathematical transformation that literally reshapes the landscape into that perfect bowl. And from there, the final step is a cakewalk. The AI just rolls straight down to the bottom to the one and only guaranteed best answer. Okay, I know what you're thinking. How do we know this reshaping trick always works? Well, that's where something called Lidskii's theorem comes in. You can think of it like the laws of physics for this whole process. It's a deep, powerful mathematical proof that guarantees the transformation from mountain range to bowl is always possible and always correct. It's the bedrock that makes this whole thing verifiable. But look, a guarantee on paper is one thing, right? The real question is, does it work in the real world? Well, the CTM framework has been tested, validated, and it's built on 3 core pillars that prove it's ready to go. So, first up, speed. Because the AI has such a clear, direct path to the solution, it just gets there faster. CTM has shown a verified 11% speed up in what's called convergence. That just means it finds the right answer more efficiently, which saves a ton of time and computing power. Next, and this is the big one, stability. This hits that unpredictability problem head-on. CTM hits an incredible 95% stability score. That means you get consistent, repeatable results you can actually count on, which for high-stakes work is absolutely everything.
And third, ethics. How do you even certify something like fairness? By measuring it. This framework has achieved a 92% ethical compliance rate, making sure the system is operating based on principles of fairness, transparency, and doing good. So when you put it all together, these three pillars are what build that foundation of trust. You've got the mathematical rigor, which guarantees how the system behaves. You've got ethical compliance to make sure the AI is fair and beneficial, and you have transparency, so the whole process is clear and auditable. This is what a truly trustworthy AI actually looks like.
So, when you combine all of this, you don't just get a slightly better algorithm. No way! You unlock a completely new era for artificial intelligence, an era that's defined by certainty and trust.
And get this isn't some pie-in-the-sky research project floating around in a lab. The Convexity Transfer Methodology has already achieved Platinum, Infinity, and Production Certified status. That means it has passed all the tough tests, and it's ready to be deployed in real-world, mission-critical systems right now.
Just think about what this unlocks. The possibilities are, well, they're staggering. We're talking about AI in medicine that we can mathematically prove is reliable. Verifiable ethical AI for finance or law. We could build global learning systems with performance guarantees, help stabilize quantum computers, and ultimately give everyone access to AI that we know is truly safe. And that brings everything full circle, back to an even bigger vision from Hussain. Causally invariant? That's a fancy way of saying the AI's core logic stays stable and predictable no matter what you throw at it. It's this complete picture where the math, the ethics, and the reliability are all woven together and guaranteed. So I want to leave you with this thought. For decades, our biggest ambitions for AI have always been held back by this risk of unpredictability. If we can now remove that risk with actual mathematical proof, what great challenges could we finally solve? What could we at last achieve?